Now you're making me nervous. Well, welcome. Thank you for coming. I'm Layla Aman. If I haven't met any of you, I'm the city manager for the city. And I have very little role tonight, which is awesome because that's rare. But I want to take a moment just to introduce the newest member of our team, and then I'm pretty much going to hand it over to him and our project manager, Jessie Steiger, who's right there. So she's from Clash Group, and she is what we call an owner's representative, but she is effectively the city's project manager. So she is really kind of running the show in many ways. And then if you remember, we have Chris from Bearing Architecture, and he is our architect. So I'd like to introduce Jason Stegner of Cove Built. We just signed a contract we're in the process of signing a contract, but City Council approved a contract with Jason to serve as our construction manager, general contractor. And what that means is that Jason will be working with Chris, Jessie, and myself as we go through the design and development process. And one of the wonderful things about having a CMGC, we'll call it, because we love acronyms, is that they're involved throughout the entire design process. So as the architect starts developing designs, Jason's at the table with us to evaluate both the constructability of those designs, but also the costs. And the costs are something that is pretty much a paramount importance to us because we are working on a very fixed budget. And so by having that relationship early in the process, we end up with a project that we can actually build in the end. Because we're kind of starting with the budget number. Jason works with the architect to say, that's crazy town, you can't do that. And here's what we could do that might actually be less expensive and more effective, and then they work together. But Chris also knows our budget, and so I'm doubtful there'll be any crazy town involved in that. One of the really cool things about bringing Jason on our team is he's local, so he lives in Arch Cape. He does a lot of projects locally, and one of the things that the committee, so there was a committee that helped select our contractor. So we went through what we call a formal procurement process. So back in January, the City Council adopted findings to exempt us from what we call a competitive bid process. So if you kind of know how public projects work, we typically have to go out to competitive bidding. So we have a project that's designed, and we say, okay, tell us how you're going to build this and for how much. As I mentioned, the CMGC process is different in the sense that the contractor is actually with us from the beginning to help create those designs, and then we ultimately lead into what they call a guaranteed maximum price. And so then if Jason can build it for that, we amend his contract to authorize those funds to then get his firm to do that. So Cove Built's local. Jason's got a lot of experience and started out as a mechanical engineer and then moved into the construction business. And worked for some of the bigger contractors in Portland, and then has been working on the coast for 10 years? 8 years. Mm-hmm. Has been involved in a number of CMGC type projects, so he's got a lot of experience doing public projects. One of the other great things about having a local contractor is that he's got a lot of relationships with local subcontractors, which is really important if you know construction out here, is to get people who can actually build it and put in the mechanical and the plumbing and all of those systems. So those relationships are really paramount to the project success, to the pricing success, and to all of those things. So we issued an RFP. Jason's firm was one of 5, actually. So we were really impressed to get so many contractors. And we got some big firms out of Portland and a couple of local firms. And their firm really rose above for a lot of reasons, as I mentioned, those relationships, but also a real understanding of how to work with the community and how to communicate how projects get built and the complexities that go into construction. And so you'll see some of that when Jason gets into action after I'm done talking.
You're setting me up here.
For success, that's what I'm doing. So we're really excited to have him on the team, and he really completes that kind of full circle. If you've seen some of my presentations in the past of all the pieces, and will be an essential and integral part of the team. So I'm really happy to have him here. And I think with that, I'm going to hand it over to Jason.
Yeah.
Welcome, Jason.
Hello, everybody. I hope you enjoyed another average, beautiful day at the coast, right? Let's hope it stays. I don't think it's going to. First of all, I want to thank the City of Manzanita for bringing me on. I've been eyeing this project for the last many years throughout its very tumultuous waters, but I actually live in Falcon Cove, and I don't have a city, so I kind of adopted many years ago Manzanita as my city. I realize that's not truly local in coastal terms. Coastal towns are very, very prideful of their small little communities. I've been here, as Layla said, for 8 years. I've worked for a large contractor in Portland, Walsh Construction, for 10 plus. I worked as a superintendent out in the field running jobs, and then I moved in as a project manager, which is kind of what I do now. Helping the jobs get off the ground, budgeting the jobs, working through the myriad of paperwork that we have to go through to build a job these days. And my family chose to leave Portland 8 years ago and come down here. I've got a 10-year-old. She's been in Fire Mountain for the last 6 years. She'll be in Neocani Middle School here next year. I started with O'Brien, and I spent 4 years with O'Brien. I ran O'Brien's construction operation for 4 years. Some notable projects, things I'm very proud of, would be the Seaside Convention Center. Nobody thought a little local company in Cannon Beach could build a $10, $11 million job, and I think we knocked it out of the park. We used a superintendent up on the Miami Foley, Troy Gruck, if you know Troy. Troy and I teamed up and we built that. My first job ever on the coast was Fresh Foods. I was the superintendent and PM. I sat in the trailer and made friends with bunnies for 9 months. And so I built Fresh Foods in Cannon Beach. We built a bunch of projects for the hospitality industry in Cannon Beach, Stephanie Inn, some hotels in Seaside. But I started feeling like I was losing my soul, my goals in life, which one of the reasons I started Co-Built was to build community-based projects. You know, so many jobs out there, there's so many opportunities, and I would rather spend my energy, and believe me, it's a lot of energy to put up a building, on something that benefits the greater good, and I think the coast really needs a good focus on building a better place for us and not necessarily for others. And so while three and a half years with Co-Built, we built the lobby for NCRD Auditorium. We won that in a hard bid and beat the Portland guys substantially. We were the reason I believe that they were able to build the project. We brought local forces. I built the covered play structures for Nehalem Elementary and Garibaldi Elementary. Those get used like every single minute of every single day. Couple tenant improvements down at Neocani High School. I built Care Inc.'s offices in Tillamook. I'm currently up in Jewel building their new gym and locker room. And all of those jobs have been about 70+ percentage points of local contractors, and that is something that I'm very prideful of, and it's very important to me. Number one, Layla hit on the head. If you can bring Diamond Heating from Seaside and their guys living in Tillamook or elsewhere, they're going to be on the job when you ask them to be like that. If you're bringing them out of Portland, it's a near impossibility. So it's really important on that one regard. And the other regard is I want to keep those dollars in the community. I want their kids to have a healthy lunch at school. I want them to be building a better community for whatever little enclave of the beach they live at. So that is what I think we're about. I want to leave it with construction can go a lot of ways. I'm sure most people in this room have had a good experience and maybe a bad experience. And I think the difference is really simple. Trust. So if you can build a trusting relationship with the team that's building your thing, you're putting a lot of money into that project. I mean, you know, you could be putting $1 million into a home these days quite easily. And if you have trust that your $1 million is being spent wisely, and you can communicate all the challenges that happen, and there's 1,000 challenges, and get to the bottom of it, at the end of it, everyone's happy. It always works like that. If you lose trust and you're in a friction environment with that person, it's miserable. It's not fun, and my goal is to earn your trust. I believe it starts and ends with ethics and how you approach the day, the world, the person you're across from. So I challenge you, if you feel like I'm not doing that for this community, call me out on it, because that is why I'm here. I think with that, Jesse's going to talk through the various reports that the team has received over the last many months and kind of the state of those reports, and I'll follow up with some of my thoughts on the existing building.
Let's switch to the next slide.
One second.
And before Jesse does that, because I have almost no role in this evening and I can't stand it, I'm just going to walk you through the agenda really quick. So, all right, so we've introduced Jason here. Jesse's going to give us a report on the reports, as Jason mentioned. We've done a number of reports over the last several months investigating the existing conditions on site. Jason's going to kind of do a tour of those facilities for us and give us his first impressions. Then he's going to kind of talk us through this constructability question, what it's like to build on that site and what are the challenges with those buildings. Then we're just going to open the floor up to a Q&A and kind of wrap it up at the end. So with that, I'm going to turn it over to Jesse.
Thanks. So yeah, we're gonna get through a bunch of technical things, and then we were trying to save like a solid 30 minutes for a Q&A. So we'd like to get through all the technical things first, and then open it up. So please, if we can go back to any of these topics and slides. We've got kind of 4 technical reports that have happened thus far. One was in 2018. It was more reflective of kind of the previous effort. Then this last year, we've had a hazardous materials report, a specific report just for the quality of the concrete, and then just recently, like last week, we got the geotechnical report. So that's new information to us. So I'm going to do a very high-level overview of these. Between all of these reports, it's hundreds of pages. Shocker, I don't have it all memorized. I do have it all on my laptop. I can look it up and try and answer questions, but I'm just going to do kind of a high-level summary of what is in those reports for you. So the WRK report in 2018 really summarized, it was a visual assessment of the facilities. What it found was a lot of deterioration and significant cracking in the concrete and the foundation. It's pretty visible. The exterior walls have a lot of deterioration and water damage from years of neglect. Likewise, the roof is not in great shape. It is ponding. There's been leaks, and also the roof joists are inadequate to support drifting snow loads, so we already know those would have to be strengthened at a minimum, if not replaced. The seismic capabilities, the ability in an earthquake for all of the loads to get from the roof level down into the foundations is inadequate. Really simply because in the 40s when this was designed and built, we didn't know a lot about earthquake engineering. It has evolved tremendously in the last, that's a 75-year-old building. In the last 75 years, it's evolved a lot in the course of my own career in the last 25 years. So we're looking at a minimum that we would need new hold downs and footings at 24 locations. So I just want to note, that would mean, let's say along the length of this wall in the school, if you can imagine, that we'd have to excavate at least 3 times to put in a new footing and new hold down anchors. And if you can just imagine, a hole this big, in the foundation here, how disruptive that would be just to this one length of wall. And then the Quonset hut, again, is a visual assessment. It's in slightly better conditions, but still leaves a lot to be desired for seismic engineering. Okay. Then we got a hazardous materials report. This was just done this year in August, September. Not a lot of great news here. As for a lot of old buildings, the mastic in the flooring all has asbestos. All of the flooring has to come out. The roof has asbestos. The whole roof has to get replaced. The drywall, the texture, the tape, the mud compound, it all has friable asbestos, which I found surprising, but that means all of the walls have to go. All of the drywall's got to go at minimum. And the exterior walls, again, with the water intrusion, there was a lot of visible mold. So even if we could save the drywall, we'd have to remediate it. If we can save the studs, it all has to get remediated. It also adds risk. Mold is not terrible to get rid of, but you have to get every little last mold molecule, and it's really difficult to do. Thank you. And then the Quonset hut. Similarly, we found asbestos in the silver paint on the roof. If you noticed, a fence went up around it recently, and that's due to the results of that report. It is friable asbestos. So as a caution, the city has put up a fence. We're working with our consultant and DEQ to figure out, do we have to abate this immediately right now and remove the roof, or can we wait a couple months is all while we finish the design and figure out what the plan is going to be. So the fence is up as a precaution to just keep people out of the zone of where that paint is. Again, our roof is leaking there. There is visible mold growth, there is some rot, and then the maintenance garage part of the Quonset hut is in worse condition, has more leaks. Okay, this is a different report. This is a MTI, is called Materials Testing Inc. And they came out and they do some testing on the concrete, and they go a little bit more in depth than just the visual assessment, but it wasn't destructive testing. They don't go in and take big chunks of concrete back to a lab and test it. We didn't take that step. So what they found, again, which kind of backs up what we found in the WRK report, lots of deterioration of the concrete. We have seen some differential settlement, which is not good. That means the foundations are moving opposite of each other in different parts of the building, or one area is settling compared to another. We found, there's a CMU wall that's cracking. So then they do this hammer test. They call it a Swiss hammer test. It seems a little silly, no?
Sorry, this is the carpenter's hammer.
The carpenter hammer. Oh, I got you. So they literally go around with a hammer and they tap, and how it sounds reflects sometimes can reflect the quality of the concrete, and that if there's voids in it, if there's deterioration, like if there's rebar that's rusting inside, it has this hollow sound. It doesn't sound like it's something that would work, but it does. I've seen it myself. So they can learn a lot just by tapping on the concrete and listening to the sound it makes. It's crazy, but it's true. We found a lot of corroded reinforcement bars in there, which means there's reinforcement in concrete. It is necessary for it to perform. When it has corroded, what happens is it starts to expand. Anytime it starts to rust, it expands, and you lose the bond in between the rebar and the concrete. Essentially, it's useless, is really the bottom line. That's about it on that one. Similarly, you can see here that 90% of the bar was lost. That's a lot of rust. You can imagine how long it takes to rust through an entire piece of rebar. So they saw that much deterioration in some locations. There's the Swiss hammer test. So again, we generally, the minimum strength of concrete we use for buildings is 3,000 pounds per square inch, 3,000 PSI. That's generally bare minimum. Frankly, modern buildings, it's almost always at least 4,000 these days. And that, as an ex-structural engineer, I would be fine if a sidewalk was 3,000 PSI, but for a building and a foundation, you often want it to be higher. The results of this were that a lot of it, when they did this test, it was even below 3,000. So what we found is a large amount of the concrete just doesn't even meet the bare minimum standards for a sidewalk. That brings us into the geotechnical report. We just got that, we got a draft of it 2 weeks ago. It just was finalized last week. We're still trying to process and understand some of the information in it. So you might have seen they had brought a drill rig out to the site. It broke down 3 times, otherwise we would have had it sooner. But they go out and they drill borings down to, I don't know how far they went, 100 feet, let's say. I'm making that up. I'd have to look that up. They go down pretty far, and they auger down. They did 5 locations on the site, and then you analyze the soil at each depth to understand the capacity of the soil to support a building. So what we found is we have a risk of liquefaction 30 to 40 feet below grade. So that means in a seismic event, in an earthquake, when the ground starts shaking, there's all these air voids in the soil profile. And that allows the groundwater to start moving up in a seismic event, and now your dirt, which was solid, now becomes soup, okay? It is not good. I don't want to scare you, but it's a new item we just learned about, and what it means is that for the police part of this building, which has to be risk category 4, that we cannot use simple spread foundations, which means ordinarily you just dig a shallow hole, you pour in a blob of concrete with some rebar, and you call it a day. That's a spread foundation. For the police station, in order to get past this liquefaction zone, we're gonna have to do these auger piles. Oh, that's on the next slide. You don't have to skip ahead, but we're gonna have to do some piles just for the police station, okay? So, and then if we choose or decide that the council chambers also needs to be risk category 4, which is your immediate occupancy, that's also gonna need piles. None of the existing buildings have that. So at a minimum, the police station will definitely have to be new construction. What else we got here? Deep foundations for risk category 4. The other thing that was in the geotech, which again wasn't standard in the 40s, is a lot of compacted gravel beneath your slab and beneath your footings. And so the geotechnical engineer had some really specific recommendations for how much gravel we need to create a compacted layer before we do the foundations. And we don't believe either of the existing buildings has that. We have some as-built that show that, but also it just wasn't done. So we don't think it's there, which adds to some risks that we really don't believe any of the foundations are likely adequate to support a renovation in place. And then lastly, there's no vapor barrier beneath the slab. Again, this wasn't done in the 40s. It is in every new building we do now, but it's not there, and it probably should be. So that's another element of why maybe trying to reuse the slab is not a great idea. More on the geotech report, again, kind of summarizing that we need quite a big lift of compacted gravel below the footings, which we don't believe is there. Kind of dials in some minimum dimensions of what we think the foundations need to be. And that's it, just going through some how deep it needs to be below grade. And I don't think we know precisely where the bottom of the footing is in the existing buildings.
We do in some cases.
In
We
some
have
cases.
limited drawings that show.
Okay, but we don't think it's necessarily 24 inches below grade. So we also have a depth problem of where the existing foundations lie. Oh God, more geotech. I forgot there's this many slides on this one. So this top note is just noting that liquefaction element to it. It complicates the foundation design. It's perhaps a slightly challenging site to design foundations for. We will need these continuous flight auger piles. I haven't exactly done that one, but that's more like a spiral auger. Is that true? Do you
Yeah,
think?
they're used all over now,
Yeah.
and it's just a helical auger. It looks like you would put on a drill rig to drill out your fence posts, and they're really easy to put in. Actually, it depends on what the soil profile is, how much rock you're going through. Here, it's mostly sand. So, what the guys do is they come out with a little mini excavator. It's got a turnbuckle on the end of it, hydraulically driven. And they put the first stick in, it drives it in, and then they take that off and they put the next stick in and it drives the next one down, and they do it in like 10-foot sections. And it's not hard to get to 40, 50 feet. They're not outrageously expensive as opposed to, say, driven H metal piles that we do in the city or something where they're banging metal into the ground.
Yeah, you don't want that. That's noisy, and so I saw the word piles. I was like, I knew somebody's gonna think it's the pounding one.
Yeah, and I
but
don't
it's
want
not
everyone
that.
to be like scared of them. It's
Yeah,
pretty
yeah.
common in construction today, and most of the local excavators have the ability to do this.
Okay.
Sorry to interrupt.
Oh, that's fine, thank you. And then, so we've got the bottom note is the piles. We're looking at having to go down about 50 feet, right? So we don't have that in the facilities now. That concludes a high-level summary of the technical reports. We will answer any questions on that later.
Gonna do
Did you
that
want the
fancy
paper?
thing? Yeah, I want it now.
I'll just add that we will make the reports all available on the
Correct.
website, right,
Yes.
Layla? So they'll be all there if you care to read hundreds of pages of
That would be
geotechnical
cool.
reports.
I don't know how much this is the laser button.
Gotcha. Cool.
Okay.
So I have a really quick question. There was never a complete geotechnical report done before.
Right.
This is the first one that's been done on the site. Okay.
Yeah.
So when I came on, the team asked me to take a drive out there and put my builder eyes on it. I feel like I'm a good builder. I'm by far not the best builder ever. I think that I always like to take my crew out, take a look at things before we dig too deep into it, and try to do a quick kind of visual assessment. What do we think about the structures before we do anything? I will say that I know that reusing the buildings is one of the many goals potentially, and I truly believe that that is the greenest thing you can do in construction. We talk a lot about LEED and all these other things. Reusing things, it should be a goal of ours in life, and so I think just as a premise, you know, that's a good place to start. But then we went and looked at the building. So this is the south side. I kind of just went around, put up letters and placards to kind of talk about where things were happening. Obviously, you can see all that longitudinal cracking. That's getting air and moisture into the rebar. And so what really happens there, I mean, the foundation probably has still decent bearing capacity. It can still take a load vertically. But what it can't do is take a load horizontally. So when wind blows against the building, how does it stay up? It stays up with shear, right? And shear is done in wood frame buildings with plywood and hold downs. And so you put up a bunch of studs and you tack plywood, and they tell us exactly how to nail that plywood onto the wall. 12 inches around the perimeter or whatever, 4 inches in the field, all that jazz. And so that plywood then adheres to the studs and it makes it rigid, right? So when something wants to blow over, all those nails are resisting that wish to tip the building over. But all that load has to get transferred to the ground. And when it hits this condition, it's compromised. It can't transfer adequately all those loads. We also put in hold downs, which are big metal Simpson brackets on the end of two shear walls, and it's trying to hold the building from doing something like that. So clearly, even on the south side, we've got two areas of cracks. Did show some of the window sills are pretty well weathered and damaged. I would say the siding in general, if this was just a building somebody asked me to walk up to, it's all compromised. It's pretty well past its useful life. You know, if you put up cedar shingles on a building, I'm going to say I'm hopeful that you're going to get 40 years out of them. I don't know when the last time this was sided, but I think it served its useful life. One other thing that happened a lot on this building, and for whatever reason, it was built very close to the ground. In other words, the concrete, we like to have about 6 inches and more is better between dirt and wood. And everything's going to grow out here. I mean, you know, if you live down on Horizon, that 6 inches is going to be gone in like 2 years with sand, right? I mean, it's just going to happen. So what happens when you're that close to the ground is water wants to wick up places like this, and the lower kind of row of siding is clearly deteriorated. Even worse though, siding can be replaced. Even worse is the sill plates. So today, when we build something, we'll pour a footing, we'll pour a stem wall, we'll put a actual foam membrane between the wood and the concrete, because concrete absorbs water and it wants to wick into wood as well. And then we'll use a pressure treated layer. With all those measures, we can keep water out of the wood part of our building. And in about as many places I opened up, I saw rotten sill plates. So it's pretty prevalent. You can see all the cracks that we're kind of noticing throughout the building. Go ahead, Chris. Here's examples of the rot in the sill. You know, the spalling, which is, I'd say, quality of concrete probably. You know, back in the 50s, whenever this was built, there were probably, I'm guessing, wasn't alive yet, but the composition of concrete it's a science. It's a mixture of rock, lime, sand, and admixtures. And today, when we go and build the footings potentially for the new building, whatever concrete, Moeller sand and gravel, A1 concrete, they're going to give us an actual mix design, and that's going to go to a structural engineer, and he's going to approve it to say that concrete should have 4,000 pounds PSI bearing, and we're putting all these things in it, and they agree to that. And then furthermore, when we pour that, we're going to have a special inspector out there with a little tube, and he's going to take a sample of that and a core. He's going to take that, he's going to take 3 of them, he's going to take them back to his lab, and he's going to break them at 7 days, 14 days, and 30 days. And he can tell us how strong that concrete is through 7, 14, and 30 days. 9 times out of 10, your first break is going to be over 4,000 PSI, and most of the concrete these days is hovering up in the 5, 6, 7,000 PSI range. My guess is that the quality of materials used without a precise science was inferior 50, 60, 70 years ago than it is today. Window sills are gone. Those are single pane windows. That does not meet today's energy code. So I would say windows are just a lost cause in the building, and there's a lot of rot. More rot in the sills. You can just see, that's 2, 3 inches from the dirt. Bugs get in there. Water wicks up there. It's going to rot. Yep. And then, so this is the worst of it for some reason. Out on the east side, closest to the Quonset hut, kind of between the Quonset hut, there is a horrible longitudinal crack down the entire length of it. You can see the rebar. The moment rebar is exposed in our environment, it's gone. I get nervous about putting rebar out on a job site for 2 weeks, much less many years. To further the conversation about what rebar really does, all concrete is strong in compression. You can put a lot of weight bearing on it this way, and you don't even need rebar for that. It's good at that. What it's bad at is tension. It'll pull apart quickly. And so what rebar does in the case of a footing is it acts as a beam. The footing wants to bend like in the shape of a banana, and that rebar, if it's adhered to the concrete, makes that composite section very strong. The moment you lose adhesion to the concrete and or compromise the steel, you've lost that beam mentality. So it's still holding the building up well, but it's not flexing well. And so if someone is to ask me to look at this building without knowing any of these reports, I'd say the concrete's gone. That's just my personal professional opinion. Are there elements of it that could be salvaged? Absolutely. But it all starts at the ground, and that's tough in our case. So a couple other things, the electrical common problem around here, our meter bases rust. We try to get stainless meter bases. They're becoming very hard to get with the current pandemic climate. Obviously, you'd want to get all those panels inside, have one meter base, have it out of stainless. This is actually inside the Quonset hut now. So the Quonset hut is better. There's no question about it. The concrete looks to be maybe a different era, but it still has its problems. There's still cracks. That crack goes all the way through the stem wall. You're losing some of that longitudinal reinforcement. You can see up there, you've got rot in some of the sills. That's right around the garage door. That's pretty common. Doesn't matter where it is. Garage doors always kind of have that problem. More cracks. So I still think it's in pretty rough shape. So that's Jason's thoughts, and I'm sure there are opinions about that. But Chris did a really great job to kind of summarize everything we've talked about. There's 4 reports, our thoughts, and so we're going to go through that building, the old elementary school, piece by piece, and kind of show you what's left out of it. So we know that the roof has asbestos. The entire roof has to come off. We know that it was poorly waterproofed. In other words, not much of a weather barrier, no flash-ins around the windows, things we do commonly today. And the windows will need to be removed and possibly moved in the case of a new design. So take those 3 elements out, and you're left with a wood box. Windows single glaze, leaky, they do not meet energy code. Clearly, you're going to burn as much energy trying to keep that building occupied as you would buying better, brand new modern windows. Windows gone. The sheetrock, sheathing. So a lot of times back in the day, and I haven't looked at all the sheathing, but they would use boards as opposed to plywood. Plywood wasn't prevalent, I'm guessing, at this time. And those boards in today's world are not an adequate shear resistance force. We've talked a little bit about the mold, and here is the kind of the final nail, and there's asbestos in the sheetrock and in the flooring. So with all that gone, we're looking at a building with a bunch of studs, right? And we specifically asked the engineers about the roof framing, thinking, well, maybe there's still something to be salvaged here. It is under stress. There are ways to re-strengthen a roof. We could have sister joists in there, but as we know, the concrete's bad. So we have, as you've seen in pictures, lots of rot in the sill plates. The framing's so close to the ground that it's going to be problematic. There's mold. And we've talked about the need for possible new window door openings. So all those studs get removed, and we're down to the foundation. The stem walls are deteriorated in many places. Anchor bolts are rusted. We have a 3-inch slab, no vapor barrier. It's pretty well cracked. We would have to, if we were to salvage this, have to come up with a pretty extensive adding of footings and extra foundation supports. The framing would have to set on a concrete curb, and not be at grade. And it's always more labor intensive to reuse that foundation. Not always, but in this case, very much so. The Kwanzaa hut, asbestos in that metal roof. So the right way to take that off is to take off each roof panel piece by piece, haul it up to Hillsborough to a hazmat facility. Framing, there is the rot in the sills. So, even if the hoop trusses are in good shape, having rot at the ground makes it very challenging to work around it. A little bit of mold here and there. Slab's cracked. I'm sure there is no vapor barrier in that. We'd have to do some coring and exploration to understand what the real depth of that slab is. And we would have to come up with some ways to hold that down to the concrete with hold downs, steel straps, whatever it may be. That's what's left. So the question is, should we salvage some studs or not? This will be most publicly funded jobs, and this one I'm sure will follow those same guidelines, are prevailing wages. Prevailing wages for a carpenter is around $65 an hour. Carpenters average, I'm going to say, in the area $30 to $40 an hour. So you can almost double your labor cost in doing a prevailing wage job. It's a great thing for our carpenters to be making higher wages. I think those dollars get put back into the community, but that's just a statement that the labor to do a prevailing wage job is very high. And so I ran through a quick estimate, and this is just an estimate. I'm sure we could shoot 1,000 holes into it, but I wanted to take a quick look at mass demo of that whole thing versus what if we try to salvage some of it. So just quick numbers, talked to Erickson as an example. We thought we could tear that whole building down for $60,000. Building's gone, we're starting from scratch. Now we need to replace the studs. Believe it or not, just the perimeter studs around that building are pretty affordable, $3,500. Wood's back down in the lower regions. That's great for our future project. There are many things that are not, but wood is one of those things that's come way back down. that's not all that goes into framing. We've got a bunch of hardware, we've got plywood, we've got hold downs, we've got header material, we've got roof joists, on and on and on. But I'm looking strictly at what are we salvaging versus what would it cost to replace. So we could take that building down in a couple weeks. I mean, it would be down quicker than you would imagine. So sum total, $63,000, add markups to that just to give it a full honest cost. We're talking about $70,000 to remove the building, haul it off to waste, and replace the studs. Now what does it cost to salvage those studs and kind of think about it from a selective demo perspective? So what would this would look like? I imagine 4 carpenters out there for 3 weeks, taking off every piece of wood, stacking up the lumber, pull the nails, clean the mold off of it. That's the cost of prevailing wages, $33,000 for 4 weeks, 4 guys for 3 weeks. We'd still need to do a bunch of mass demo. So all the rest of it still has to get hauled away. Hauling and trucking is a big part of any excavation or any mass demo costs. So $40,000, we still have to pull up all the concrete, that's a big part of it, and then haul the rest of it off to the site. Assuming that a third of those studs are not in great shape, we'd still have to buy some new studs. We then have to store them for 3, 4, or 5 months while we're ready for the job to kind of come together. Subtotal of $78,000, and here's a real kicker. We added 3 weeks to the schedule, so it's a 5-week process versus a 2-week process. Bringing trailers, superintendents, porta potties, all those things on site would cost us potentially $20,000 plus markups. So to salvage those little bit of studs, we would spend an extra, in theory, $38,000. Yes?
I didn't see anything in here that deals with the asbestos remediation. Something that has asbestos, there's a lot of extra cost. You have to hire specialized contractors to handle it. And that's a significant.
Excellent question. Excellent question. The remediation of the asbestos has to happen either way, so I took it out of the calculation. So before we ever even walk on site to either tear it down to the ground or selectively tear it down to the ground, we have to hire a specialized contractor that specializes in asbestos removal only. That thing will get tarped and tented. They'll all be wearing bunny suits with masks. We'll put a negative air machine in there, and they'll take out every piece of drywall, every piece of flooring, all the roof, the steel panels off. It's a big number, but it's not included in either side of the equation.
Well, that would be good to know that number, because that also, taking it out is one part of it, hiring the specialized contractors, but also the disposal has to happen at specialized.
Absolutely right. Yep, it's a big number.
So what do we?
Do you want to talk about that, Jesse?
Yeah, that will be part of the overall budget. We just got Jason under contract last week, so there wasn't really time to put together a full cost estimate for an entire project. This is an example of just one part of the overall budget, but we still have to show you like the whole budget for the whole project, and the asbestos removal will be part of that. And like Jason said, it has to happen in any project we do, and it's a sunk cost no matter what the project is. So it's not reflected here at this time.
This exercise is a bit academic, granted. I've been estimating for about half my life, but there's always errors in estimates. I think that there's always things you can perfect. I wanted to give my brain, my thought, my estimating background on what it would cost to salvage those studs versus haul them off, and I think it's somewhere in this vicinity.
Did I understand right earlier? You were saying the removing the friable asbestos on the Quonset hut has to be done whether we build a city hall or not.
Yes, sir.
Okay.
And I believe that all of the asbestos needs to come out of the elementary school regardless of that as well.
Whether we do anything else with the building or not.
That's my professional opinion, yes. I mean, you don't want to leave asbestos out in the world, right? I think that's just a commonality. Yes, sir.
Is there any projection at this point what those asbestos and hazardous removal costs are?
Yeah, you had.
We're working on it.
You
Yep.
did have a number earlier, I think.
Yeah, so we brought in, a couple weeks ago, we brought in a contractor that I'd worked with for years in Portland, AAC. I wanted to get a number for the abatement. This is by memory. I believe that just doing the Quonset hut alone, and that's taking all those metal pieces off the Quonset hut, is in the range of $40,000.
And that doesn't include anything.
Doesn't include taking down the rest of the
in the school
building. That's right, and it's about $100,000 on just the elementary
Holy
school.
shit. So before you even start, you're talking $150,000 before you even start demo.
Yes,
True story.
construction's expensive.
Well, no, it's not, it's an added cost of buying the property. That's basically what it is.
I mean, any building post, or earlier than the 70s has abatement.
Sure.
It is super common. It's always a risk until you quantify it for sure.
It's heavy. I mean, there's more asbestos in that elementary school than I would have guessed from my years of experience, but
It was built right during the asbestos period.
right in the thick of it.
Right.
Yeah, no doubt about it. Well, there you go. Questions?
Another question, I think this is probably for you, because you're the report lady. The liquefaction that the geotech found, is that a fairly widespread thing in the city? Did they indicate anything like that?
I think it is, I believe it is common on the coast, and because there's a lot of sandy soils, and sandy soils tends to leave a lot of voids. There's not a lot of like clay mixed in to have a lot of compaction. So I believe it is a fairly common occurrence in the coastal area.
Yeah, it's very region by region from my experience. Rarely, if we're talking about home construction, is it anything that ever comes up. And we even had our geotechs say that you really only have to worry about this for the high risk category, right? So if we were going to build offices for anybody on that site, we probably wouldn't give it too much thought.
Yeah,
If
if
we're
it's all,
going to rebuild this building, we wouldn't need to worry about it, but it's the police station aspect that causes it to be an issue on this one.
if you were here for the last meeting, we talked a little bit about the risk categories. There's,
I know those.
yeah, okay, so you know.
So basically, you're saying, for most of the buildings here, the buildings are just gonna float, it can liquefy itself, it doesn't really matter.
There's obviously a design for that,
But
spread footing foundation, it doesn't
add
have
1.5,
Yeah.
and then.
Once you increase that factor of safety, now you need a bigger foundation for that zone of the building.
Just because you've got more lateral load, you're trying to.
Can I follow on that question and ask, did the geotech look at the entire property or just the part along the street where the buildings are?
Good
And
question.
is there a difference between building on the back of the site and?
That is an excellent question. I'm going to say off the top of my head, I believe the borings were in the zone of where we think the building site is going to be, which is really right up around the existing school and the existing Quonset hut. And that we did, maybe one boring in the back?
Yeah, I think.
Yeah.
I have to look at the.
We walk our dogs around there and I did see one further
Okay.
into the.
Okay, so we have a piece of information from the rest of the site, but we concentrated the effort more on what we believe the building site to be. Probably between that and where the farmer's market is, I'd say in general, it would be odd to have huge differences in what we find.
It seemed like
could
it.
happen.
Yeah.
Any question, any other technical questions, anything that we saw?
How deep is the sand there? I just assume this is all a big sand pile that we're living on.
It was the whole first like 10 feet or something at least was pretty solid.
When it got back into sand, lower, didn't it?
Correct, yeah, and then it did some gravelly, and then when it went to back into sand, it's a lot, yeah. Yeah,
I have a different type of question, Jason, if you were to go on to the construction phase of this project, Do you pre-qual your subcontractors, and if you do, how do you do that?
Yeah, good question.
Within the confines of the
So
public?
the thing about a CMGC is that I competed competitively. That was not strictly numbers based, right? There's a little bit of numbers based GC's fee, and then it was experience, qualifications. When I take this out to bid, it will be a public bid process for the subs. I can't just go, hey, I'm going to call up my favorite 3 guys and put a number to this. That's the one caveat with the CMGC is that they now make me, so I'm going to have to go.
But you could pre-qual them.
Absolutely, absolutely. How would I pre-qual them? Well, I think in all cases, if I don't know somebody, I'm usually trying to make some calls to understand what their background is. I'm asking for references. CCB helps us here a little bit. I always do a CCB check to make sure that they've kind of mastered all the basic paperwork. I've got a lot of friends in Portland, and I have made those calls before in this industry. But, most people that are going to provide a significant portion of this usually are pretty known quantity. In some cases, I'll find I'm doing a health center for Tillamook this winter, and a siter called me. I'd never heard of them. I made 3 or 4 calls and found out enough about them that I needed to know. But it seems to me, this economy is kind of interesting. We're going to see more out-of-town bidders once we get to that point than we have in the last 8 years. I'm already starting to see it. People are starting to come down here. In the last 6 years, I would beg for bids, right? I would make sure I had coverage from, the 3 or 4 really good electricians around here, Intel Electric, Miami Electric, Bogue, etc., Cannon Beach Electric, Diamond Heating, P&L Johnson, Haltner's, Terry's Plumbing, North Coast Mechanical, Mark Alsop, et cetera, et cetera. So I would be calling those guys actively saying, all right, I need you on this. It's coming out here. I can provide you any help that you need to get through bid. I can help you with takeoff if you need to get to it. I have as much interest in providing the best set of subs as anybody. I'm only going to be successful, and I'm only successful with the right team around me. My guys are maybe 15% of the entire project. We do have a carpenter base of about a dozen guys. They live between here and Tillamook. I think they're the best carpenters in the region.
That work directly for you?
That's true. One thing I will state, I'm probably going to soapbox a little bit here, but the quality of carpenters and craftsmanship on the coast is amazing. It's truly a very special set of skills that these guys and women have learned living down here. It takes the right kind of person to sit out there and hammer nails in that wind and rain all day long. But it's really cool to watch, and I'm always very prideful to have local guys that are building your thing, and I think that's a good thing for our world and community.
Absolutely.
Did I answer the question? Okay.
You had talked about a guaranteed max contract for
Yes,
the
sir.
city.
That's correct.
Are you going to look at any incentives to do the project to save the city money in some way? How do you guys look at that?
Yeah, so I think those are 2 different things. I will be signing a guaranteed maximum price contract, which basically says I have to get it done for that cost, and the rest of the risk is on me. So it puts a lot of pressure in making sure that I have the right number put together, and I'm pretty good at that. We do carry contingencies, and those contingencies, in my mind, are a little bit on the owner's side and a little bit on the contractor's side, but I like to be pretty open book about all of it. I want you to know where the money's going. We're going to miss things. There's classic examples. I may not see a steel column in the corner that was the one column that showed up at steel, and that just got missed. That's why we have contingencies, those little kind of gotchas as the job goes along. If we have the right contingencies, I put the right effort into bidding, we're going to get to a price that I feel 100% confident in. That's why we get paid, right? your second question is, how are we going to bring value
Well,
to
is
the?
there a mechanism for the city to save money?
Yeah, that can be written contractually in a lot of
during
ways.
the process?
Absolutely.
If prices go down, or, I mean,
Yes.
Absolutely.
Yeah,
Yeah.
and that's how our contracts are written.
That's
So
right.
There's a contingency bucket, and generally how it works is Jason's like, oh, we had this error, we need to spend $5,000 to correct this. I say, yeah, that makes sense, and we approve it. Anything that is unused in the contingency returns back to the city.
And the contract, for that matter.
Correct, and so we all work together to manage that, and
So-
frankly, their incentive is to get it in budget, otherwise there is no project to build.
So is it essentially T&M against the
No.
GMP?
No,
Yes, it is. It's against the GMP. That's a better way to say it.
yeah.
So, but it's T&M against the GMP.
These AIA contracts are written such
So
that
whatever
all
you
savings
don't
go back
spend-
to the city of
Whatever you
Benson.
don't spend goes back to the
That's
city.
true
but you're
statement.
not talking about doing T&M
No.
contracts with Diamond or?
Nope.
No,
Nope.
no.
You're talking about.
I'll have
doing
lump sum
actual
contracts with them.
subcontract with them.
Right.
And
What are you talking, TMI, I don't
Time
know.
and
Time and
material.
Time and material.
yeah, so let's
Some
say
of
we
the
sign a
contracts are
three.
lump sum, but
Let's say we sign a $3 million contract, and that's what we think. We've got our contingencies built in that. We're off and running, and lumber does come back down, right? So it was a high lumber price, and I threw $100,000 at lumber, and actual costs were $50,000, and we did well throughout the rest of the job. Let's say we saved $60,000 on $3 million. That's yours, not mine. It's that simple. Is there more incentive in that? Sometimes we'll write incentive clauses into contracts, such as if you get it done earlier, we'll incentivize you. If you get it done for yeah, I mean, in the end, I truly believe like we're going to shoot for a GMP. We're going to all have budget and value engineering deep in our mind. We're going to work really well together to make sure we've got all the parts and pieces figured out. And something comes up and we were like, hey man, this is a better cost. Let's say we're going to put cedar around the whole thing, and finally we're like, you know what, we're going to save the money and put Hardy on it. Some people love it, some people hate it. It costs less, I can promise you right now. As in like a half to a third.
But then you gotta paint it.
And then you got to paint it, and then you got to maintain it over 20 years. So there's all kinds of factors,
Part
but
of the math we do as part of design, we've got different options. We've got the operational and maintenance costs. Sometimes it's better to spend more money upfront for a product that lasts longer. I mean, sometimes you choose to buy something more expensive because you know it'll last you longer, and we're gonna do that same process.
I love a CMGC process because it puts us together.
right.
What happens in the opposite field is that Chris is off in Portland and he's designing a beautiful building, and I'm sure he will, and he hands it up to a bunch of people and we all bid on it, and then we get to the field and we're like, yeah, that's wrong and that's wrong and that's going to cost you more money, and there's that thing and that didn't get foreseen. And I guarantee you, in a lump sum hard bid environment, the cost is going to be more than it was at the beginning, and we're going to miss 1,000 constructability things along the way where Chris said, hey Jason, and or Diamond and or Inland Electric, what's the right way to do this? Let's bring those guys in the room. Let's say, skip it. Let's not even go into all of that deep design. Diamond says we should put a package unit out there as opposed to 40 mini splits. That's the best value. We kind of flush it through some engineers and we're off and running. So it really gets us in a team environment. And in my experience, in my 20 years and probably 10 of these, it always works if you've got the right team and you build the trust with the client. Yes, sir.
Can I ask one more question? So it seems pretty apparent that the team is heading toward new construction. At what point, and this may be the team, it may be the city, at what point is the nail in the coffin about using the existing building?
Well, that's a segue. So, okay. When we started this process, when we started this public process, it was our charge to look at renovation options and new construction. And we've done that. We have a new construction idea, we have a school reuse idea, we have a Quonset idea. Then we learned more about hazardous materials. Then we learned more about the concrete. Then we learned more about the geotech. Then we got Jason on board, and it's increasing our knowledge, right, of the existing conditions with each phase. I will say at this point, we're all looking at it like the concrete's bad. If we don't have a good foundation, these buildings, if we reuse them, they have to come apart. They have to get stacked on the side if we're gonna choose to make reuse. It's really a rebuild. It's not a remodel, it's a rebuild. And at this point, we are convinced that a rebuild option will be costing more. And what we heard, I think, overwhelmingly from the first meeting is that cost on this project is a very high priority, that you want a city hall, but we want it to be cost effective. So as a team, we can do whatever the city wants us to do. We can find a way to keep this intact and rebuild it. It is going to cost more money. Whatever the city wants us to do, we can figure out how to address. Right now, it's looking like new construction is the most cost-effective option for us. And so what we wanted to pose to you, right, is the next question. Is that right?
Well, that's our kind of summary.
Oh yeah, I just did all that. Let's pretend I just did all that. That should we keep pursuing the idea that we can rebuild the school or the Quonset hut, and we want to be cost effective, and it feels like we're kind of spinning our wheels and starting to waste money the more we look at it, and we don't want to do that. So, but this is a community decision, it's a city council decision. Do we keep pursuing this, or do we change our focus and say, we've done the due diligence, we realize now with all of the information that new construction is the most affordable, and should we pivot to that and just keep working on that scheme? And so I think that's a discussion that we should be having as a group, and that was what we wanted to discuss.
And I'll just kind of add to that. I mean, I think kind of put another way, to reuse the building is to rebuild it. And so does it make sense to rebuild this building in its current configuration and fit the program into it, or kind of get rid of that constraint? I think is the way we're seeing it, because we could maybe keep parts of it at some greater expense, but the foundation needs to be replaced, you know. So that's our, and as Jesse said, this is not our decision to make. We're gonna deliver for you guys what the city and the city council asked us to do. But this is kind of where we are now.
We have some ideas about how to acknowledge the architect and the reuse, for instance. Like, we could still salvage some of those studs and maybe reuse them in the council chambers, for instance, as like a wall cladding, or maybe there's something in the lobby that's a story about the architect and her contribution, right? Like, that's amazing to have a female architect at that time design a building. I love it. I wish the foundation was in better shape. So, I don't know. Who's got a thought?
You looking for a motion?
No,
You know, I do recall when they redid the Arch Cave Tunnel, they kept some sections of that really rotted out cedar wood and made little plaques of it to show people what that looked like, and that's why they had to replace the thing and shotcrete it. So.
And they also gave away all of those slabs that people used in their gardens.
Yeah.
And they were, you know, people were using hazmat to do the work in there. And then other people came and they were in gardens all over the area.
Hey, I have a piece
So I
of
don't know
carpet
about
from
that.
the Portland airport.
Right. So I think that level of kind of reuse, I mean, the light fixtures in the school are great. They're great, beautiful kind of 40s, 50s era stuff. We're gonna salvage everything that we can salvage.
What about the bent beams for the Quonset hut? Can you work those?
That's a
into some
great
sort of-
question.
I think, you
That's a
know, I
great
think,
question.
again, without having the full analysis, the concern now is, you know, the code requirements for snow loading are different than they were back then. So to use it as a Quonset hut and put a roof on it, maybe not, but to use it as a trellis
But you
piece.
could double those trusses
Yeah.
up and make half the size building and do something that just
Exactly,
integrates
yeah.
into the new
Or
city hall.
something
Exactly.
outside.
Or something,
Exactly.
yeah, exactly, or something,
Exactly.
a drive-through, whatever.
Absolutely. I think, you know, there's,
Build a Sally Port for the police station.
yeah, I think I mean, as
That won't be
we've all, I
legal
think,
for.
said,
Huh?
we
That won't
really,
be this category for.
well, yeah, but I mean, there's lots of, I
But
think,
maybe
creative
for
things we
Sally
can
Port,
do
yeah.
with the parts, you know, that we're kind of excited about getting into, but we want to make sure that that's the kind of ethic that we're kind of trying to pursue here, rather than trying to, you know, save this thing, which is really going to be hard to save.
You had your hand up?
Yes, I appreciate all the work that everybody's done here. But I'm gonna go back to the WRK report. And they looked at the same thing that all you guys did, and they came to a different conclusion. They looked at what was wrong with the building, and yes, there is some rot, they identified those spots. They looked at the concrete, they looked at where that concrete was not adequate, and they addressed that problem. I mean, to say that all the concrete is bad is just a general statement. I don't believe that's true, and examining it myself. WRK said that the west wall was bad, I mean, the whole west wall, and so that framing needed to be replaced. They had a fix for the concrete on that side. On the east side where it's bad, they had a fix for that. You got the whole north side that appears to be pretty solid. You got all the interior walls that appear to be pretty solid. The WRK report addressed that. They quantified it. They applied unit cost to it, and they came up with a price of $243 a square foot to rehab that building, and that's to a school building. I've looked at this quite a while. The Sweet Home project, they took an existing building and totally gutted it and redid the interior, electrical, plumbing, mechanical, drywall, the whole shebang. And they did that for about $124 a square foot. According to the WRK report, and I would like to hear that, I would like to see that engineer here again and have him explain what he did and why he did it and why he came up with the figures he did and whether or not he thought it was a salvageable building. Because I still think it is. And just rehabbing the shell, now you're right, the siding goes, the roofing goes. I'm in disagreement with the structure of the roof. I think the WRK addressed that. They located where the snow loading was critical, and they addressed that problem. So what you have is you can take the portion, and I've explained this to a number of people before, you take the portion of the WRK report that just addresses the shell, which is the windows, the siding, replacing the rot, fixing the concrete where it is an issue, and rebuild the shell. And when you take that portion out of the WRK report, it's about $100 a square foot. You add those two together, you're up to $224 a square foot. Now that's pretty cheap. Now that could be off by, I don't know. The WRK report has 55% contingency in it. So that you know, that's pretty solid. And the Sweet Home project, those are actual costs. This is what it cost them. And it's the whole project. It was whatever engineering, whatever architect they needed, and it was a whole ball of wax. And that came out to $124 a square foot. So I'm not convinced that that building is not usable. And the WRK report says, yes, it is usable. And they show how to correct it, the seismic problems in it as well. So what we're dealing with is opinions here, except for the WRK report says, this is where the problems are, this is how many pieces need to be replaced, this is what it costs to replace it. And they put together the whole package. And I looked at what they did there, and I couldn't see any problems with it.
So the WRK report, we have new information since that came out. We have extra foundation information, we have extra geotechnical information. Did you add that cost slide? Or
I do, yeah, I'll get to that. And we've
Okay.
also, had our structural engineers look at that report. For example, they're talking about shear tie downs, right? And their response is to just, chip away the concrete and pour new concrete, set your anchors. That concrete, as we test its PSI strength, as we look at the drawings and see there's no rebar in it, getting that solution is not necessarily a solution, right? When our engineers look at that, they think, we don't know how much concrete we're going to have to chip away and re-pour in order to make a foundation that a shear tie can go into. So there's a lot about that report that is, it's a visual inspection. There was no hammer test done, right? There was no hazmat report done. They've got a $30,000 interior finishes budget in that $240 a square foot. That's $5 a square foot for finishes. So
You can't even remodel bathrooms.
what that cost is, it's to stabilize the building as it is and patch up the holes you make when you do that work. But it's also not informed by the geotech or by the hammer test. So that's why, in our opinions.
Yeah, I think the
that report-
geotech speaks so strongly to me, as they often do in our region, right? I mean, we've learned a lot about our dirt around here. And, well, sand, duff, whatever you want to call it. And yeah, I think that to me, a lot of what you said is, I think, factually correct, but it all has to, we talk about starting at the concrete, it has to start in the earth, right? And we now have learned about this liquefaction challenge. I think that the geotech, if we give it its honest due worth, that it kind of throws the rest of it out, because you need to start with excavating bad soils, laying down 15 inches of gravel, and I think furthermore, this is maybe a Jason opinion, but we're hoping to build a 50 to 100 year building on something, and I personally think that I would have a lot more confidence in that with brand new concrete.
It would be a different story if the concrete was in better condition, but there's so much of that.
Yeah, I think so.
There's also a lot of risk with it, and that we can't know 100% of the whole, of everything while we design it, because it requires all destructive testing. And so what we have to do is build in a big contingency so that if we cut Jason loose on really chipping away my hand, all these areas of concrete and patching, and then we've got to now, the engineer has to work on assumptions. So we assume that 50% has to be done back to a certain depth. If he gets in there and it's more than that, now we've got to bring the engineer out. It has delays, it has a lot of extra costs, and it's work by hand. It's very expensive. And so anything can be done. We think this is risky, or we think it's expensive. And that's really the conclusion we've come to by getting all of these reports and analyzing the data, working with our whole consultant team. And it's frankly, like we're all aligned on this, is that it's really risky. It can get done. If the city's like, we love this building, we want to save it, and it needs to stay, we'll find a way to do this. We just think it's going to come at extra cost, possibly significant extra cost.
Now, is Cannon Beach aware of all these extra costs, because they seem to be going ahead with remodeling their school?
I don't know.
Well, it's a very different building. So
It's
that
the same-
building
it's
is
the
not
same
wood
as-
framed.
it's
It's
the same.
made out of concrete.
What?
And the condition of that building is very different. And so I welcome you to certainly look at the reports they've put together, but it's apples and oranges.
And look at the total cost of that project. A couple meetings ago, when the mayor was here, I asked him about that. And for some reason, the people in Manzanita seem to be misunderstanding the total cost of that project.
Well, their initial cost for rehabbing the school building itself and not the Quonset hut was around $265 a square foot. Now, I don't know where it's going from there.
It's
But
high,
they-
it's north of
they-
8 million.
Yeah, exactly.
Well, that's for the whole project.
Right.
Even
And that's for the
still.
Quonset hut, and that's for the school building, and that's for the grounds, and that's the whole program.
That
And to your
building
point
is in
that-
far
to-
better
To your
condition.
point, that that's a concrete building up there, that's not a concrete building, it's a wood frame building.
Either way, that building itself is $8 million.
That's what I was
It's a very
referring to.
different
For some
situation.
reason, I've heard quotes about that project which were completely different than the total cost of what the mayor indicated to me his project costs were.
It's very difficult to compare two projects. I think it's very tempting. I've tried to do it myself a million times. The challenge is every construction project is unique. The soil profile here is going to be different than the soil profile across the street. Even if there was a 5-year difference in when the buildings were built, that's going to change some of the features. Like, there's so many differences, and you almost have to have like a master's thesis to really do a side-by-side comparison. And because there's so many specifics to each construction project, it's a hard exercise to really come up with proper comparable costs. And it's tempting to want to do. I get why it gets done, but it is really difficult to do it with accuracy. It requires a lot of data and analysis time.
I also think something we're not talking about is when you start fresh and you design a program under a program for the police station, chambers, city hall offices, public works, whatever it may be. Good creative architects can find efficiency in design that we are not going to have trying to work around an existing box. And I believe from years of doing this that efficient design costs less. You can spend a lot of money doing this thing because it either had historical perspective or you just went down that pathway. But that's the beauty of hiring a great architecture firm such as Baring to come in and take the city needs and try to find the right solution. And that's where I come in. We start working on, hey Chris, you just designed the Taj Mahal and we need to like roll it back because it's not going to work, right? And we have those honest conversations, and we have very distinct budget goals going into it, and it's a real yin-yang process until you find that magic balance. But in my experience with the right team, you usually find it.
That was a Jason opinion.
That was a Jason opinion. That's absolutely correct.
Any other thoughts, comments, questions?
So do we need a motion?
Do you want to take a vote? Like, what do you?
No.
And that's up to the council.
Right,
We do want folks' feedback, and one of the things we'll do, as we've done with all of these, is this presentation and Q&A. We're live on TV right now. That'll be on the city's website, and then we'll do essentially a survey. We'll ask if you're a voter or not. And we'll ask you this question, because we honestly want to get the community's feedback on this, and that, I think, will help inform city council's next move. We talked a lot about cost efficiency. We pay resources to these folks to run these scenarios and analyses. We took an honest, hard crack at looking at, can we renovate this building more cost effectively than we can building new construction. It was very important to me personally, because of the many people I've talked to in the community, but also to my council, to really take a hard look at this, to do the additional analysis that we've done, to be able to make an informed decision about what the next steps are. So what you're hearing here, although we have some professional opinion, it's based on data and it's based on really good, solid information. And so I think fundamentally, this is the question we're asking, and we want your honest feedback. Do we keep looking at a rebuild? And we know it's a rebuild. We've actually known that pretty much all along, even in talking with folks about a renovation, we knew it wouldn't be a renovation, it would be a rebuild. Is that something that's a community value? And we want to hear that from you. Or do we start to focus our resources on proceeding with the new design option, which means we can explore a few options, and then we start to look at choosing from those and presenting an option to council that has, I think, the information and Jason's expertise involved in that to help us get to a meaningful cost estimate that we can then move forward and move into the later stages of design. We're still in such the early stages of design because we really want to have this robust community conversation, get your feedback on it, and then use that to help inform the decision making. And that's really going to be up to the city council. And if, you know, in my experience, having good community input and feedback on a major decision like this helps our council make a more informed decision. And so that's ultimately where we want to go. I came at this completely agnostic in terms of whether it's a rebuild or a renovation, and so did my team. And that was really kind of their marching orders when I came in, is we had some previous work done, but we need to look at this from a whole new perspective and see where we land. And this is where we landed based on good analysis and good data and good feedback from people who are professionals who have that subject matter expertise to help weigh in on this. There's no bias towards one or the other. Ultimately, as a steward of your public resources and making recommendations to city council, I want to make sure what we put forward has the least risk, because renovation risk and other risk factors do affect costs. And once you start down that path, it can be kind of scary. But if the value of the community is that, then we take that risk, but we take it knowingly. And that's the kind of information that we want to be able to present to council. We get an overwhelming say, like, we want this building, we want it designed the way that it was, and we want it to look the way that it was, and that's important to us, then we have to put that value behind some dollar signs. And so for council to make an informed decision, we have to be able to put all that data in front of them and share with them the values that you have. So it really is an honest question, and we'd be happy to hear your thoughts on it right now, but we will be putting this up on the website, we will be asking folks to weigh in on this, and then we will compile that information, and then I'll work with the design team on what our next steps are. And likely that'll be a briefing with city council to get direction from them on which way do we go. Because I personally don't want to spend any more money going down a track that will lead us to nowhere. What I'd like to do is get us on a track that starts moving us forward in a meaningful and cost-effective way. Because bottom line, that's really what it comes down to. But we also want something that the community feels good about, that they feel engaged about. And we talked about rebuilding trust. That's a big part of it, is that your opinion does matter and it will influence the outcome. So that's kind of where we're at. So when we're done today, we're going to wrap this all up, pack it up all nice and tidy. We're going to put up all the new studies so that if you want to look at those and look at that data, you will be welcome to. Because everything is an open book. Everything is public. It's all transparent. And so all that data will be posted. You can nerd out on the geotech if you want.
It's
I totally
fun
do.
reading, let me tell you.
It is. You get some really cool words. But we are also going to ask you for your feedback on this. And we're going to keep that open for a while so that we get as much input as we possibly can. We know who's providing that input. So I think with that, I certainly would welcome any more comments or feedback. But just know this isn't the end.
When you put all of that information up, can you also remind us what were the priorities that we set at our first conversation? Because I think we were pretty clear about what we wanted out of a new city hall, however we did it. And it would be really helpful to have those values in front of us as we think about this. I know cost effectiveness was one of them. Yeah. And I can't for the life of me remember the others. So that's why it would be really helpful.
That's a great suggestion.
So that we can kind of put all that together. Because cost effectiveness is a big piece, safety is another big piece. Yeah. But I know that there were others. And so if you,
yeah, that's a great suggestion. Yeah. We'll do that.
I also wanted to suggest maybe a modification to this question is the rebuilding, preserving that piece of history, maybe it has an acceptable cost premium to pursue, right? So maybe there's a question like, if we keep, if the costs are the same for new versus rebuild, should we rebuild? If it's a little bit more, how much do you want to put into it? If it's 5% more, should we pursue it? What if it's 20% more? Is that too much? Like some sort of value to it? Yeah, I don't know. I'm spitballing here. I don't know the answer. I'm surprising everybody with special answers.
From everything you presented, it's not feasible to use that building. It is feasible to piecemeal it and save part of it, redo the foundation, and build it back. If that's really what we're talking about. We're not saving anything that, other than some wall studs. The history isn't in the wall studs.
Right.
So, and I don't know whether anybody is suggesting we build a piece of it back to look just like it does now. Because really the city admin buildings is all that really fits in there. If you're gonna do a new police station, you gotta do risk category for it. Not feasible any other way. You could do maybe cram a city hall in there or an assembly hall. Probably not. So you're gonna end up rebuilding that. So I can't remember from the original, the original meeting we had when you threw up the program information and how big the city admin building was, but it was 1,500 square feet or something like that. So, maybe if we wanna, maybe we save 1,500 square feet of that school building, which isn't much of it. And when I say save it, I mean tear the whole thing down and rebuild 1,500 square feet that look like the old school. Personally, don't think it's worth it, but I would throw that out as a, if it historically is significant to us, we could do that. Not with that much expense, really.
I would offer too that once we get to a direction, some of the feedback we can ask from folks is, should we be designing a building that speaks to the architecture of this, this structure? And so, the transom windows and the way we use daylight and things like that. So there's ways that the architect can incorporate elements of that design to reflect and to nod to that history.
Well, realistically, we designed buildings to some extent. 80 years ago, we designed buildings that were more environmentally friendly.
Isn't that ironic?
Than they are
Going
now.
back to what we did before.
Right, and that's just history, and so
Well,
you could do some of the same.
Absolutely, and I think there's lots of different ways and kind of interesting ways to think about that problem, right? If we kind of free ourselves from we're using this envelope and rebuilding it.
Right.
Whether
We use
it's,
some of the ideas.
yeah, we can use the ideas, we can replicate its language, we could decommission parts of it and make, we could reuse light fixtures, we could use the wood from the Quonset hut to build trellises. There's lots of ways we could kind of pursue that I think would personally still have meaning, but it's not, the meaning of reusing this.
Sure, I would love to see something with that shape on the site.
The
Doesn't
current,
have to be anything other than a trellis or a patio or something like that.
the current visitor center echoed the shape and the roof line of the old Kent Price Colwell Baker building that was one of the original real estate offices in town. So, so it looks kind of like it did, even though it's a new building.
So there's a precedent for that.
Yeah. Well, once we get past this step, we can start to have fun. That sort of stuff.
Do you know if the Quonset hut was part of the original construction, or it was built much later, right?
It was later, I'm not sure how much
We
later.
don't know how long precisely. We think it was, within like maybe 5 years. It's not like 20 years old.
So not necessarily part of the original architectural design, It was like years later, we need a big storage area.
I think it was their gymnasium.
Oh,
Was there a
okay.
So I think, but it may have happened
Okay.
in the 50s instead of the 40s.
That makes more
Yeah.
sense.
I've
yeah.
always assumed it was war surplus.
Yeah, I
That's
suspect it
the
was,
lore.
that's the
The restaurant, what's the restaurant on the Manzanita Lighthouse? Was a bowling alley, and it was barracks before that, came from, I think, somewhere up north.
Well, there used to be another Quonset hut up there near Mansfield Fresh Foods.
Oh, yeah, well,
I don't know where that came from, or who did that,
they
but.
all came from World War II surplus.
Yeah, they all came from World War II surface. Yeesh. Okay.
I would just think moving forward with a new building is certainly the way to go. I mean, I think one of the things that you were saying about, I was a builder and a project manager for 50 years, and just the time that a project starts and the amount of money that gets spent, the longer the project goes on.
I agree.
They have a cost. And those remodels are just such a can of worms. Well, it's not a remodel, but every time you turn around, something's not square, something.
Yeah, there's definitely risk, right? When you're working on something old, it may go perfectly, and I've had them go perfectly, and it may just go horribly, and you just don't know the answer to that until you're in the middle of it.
Yeah, and the problem is the cost that would suddenly pop up if you're running down that wrong path.
That's
That
right.
path is far more than if you just scrape the thing, put in your 15 inches of gravel, and just start over again.
Yeah, I think
Find
you
a way-
certainly have a known cost at that point,
Mhm.
and it's, we live in crazy times, right? I mean,
No shit. I mean,
that, for lots of reasons, but that was a hard year of building. Let's say 2 years of building, and that was, I built 3 houses in Manzanita last year, and it was just like, what's going to hit me next, right? Sheet metal guy calls and says, metal just went up by 1/3. Great. Glass said it happened almost daily. We are stabilizing, and I think that my hope for me and you is that by the time this gets built, we are starting to kind of get back to what I'm comfortable with, which is, yeah, we're going to see some bumps along the way. We plan for those bumps. Hopefully we don't spend it, but we get there. And I truly believe if we've done our hard work and we put the right nuts in the pot, it always works. It always works. Oh.
You don't tell us about
Well, you guys have done a great job getting the information out and putting all this together and putting teams together. It's really heartening to see.
Good, thank you. We have put a lot of effort to it, and like Layla said, we didn't come into this with preconceived notions. We've spent a lot of time really trying to figure out how to make this work, and just that we have all of this data that's pointing to this is expensive and difficult, and this is where we're at. This is our professional opinion. So, I'm sorry, I don't know. Can't help it that this is what the data is. It's just kind of how things landed. So. That's where we're at for tonight.
Thank you for your time. Keep an eye on the website. Look forward to hearing from you. You know how to reach me otherwise.
You're very brave. I used to be an orange kid.